Hello everyone, this is part 4 of the tutorial. So now that we have finished modeling a model in Microstran, so the next thing that we need to do is we're going to start defining our dead load, live load and wind load according to IS 117.0.2. So make sure you have to stick around to the end of this video so that you can learn as much as content as possible. So in order for us to start defining our load, we have to go to Excel and start defining our load cases. So we have live load on roof, we have dead load, we have under dead load, we have sheeting load, we have ceiling load, we have balance, and here we have comments. Okay, so in order for us to get the live load, we have to go and get the value inside the standard code. So I'll go to table 3.2 is 417.0.1, where it says impose live load for roof action. So we have two values. We have uniform distributed action, we have concentrated action. So for the uniformly distributed action, we have 1.5 kilonewton per meter square and 1.0. When you read the specific use, on the table it says accessible from adjacent window, roof, or balconies. No, I don't need this, but I don't need this. There's no balcony on the roof. Accessible only from the ground level, which is 1.0. Then concentrated action, which is 1.8 kilonewton. So I don't need this value on the table. So I have to skip that and then go below. Below it says for structural element. Of course, I need this because I'm going to apply my live load in the structure. So I'm going to choose this option for now. So we have two values. We have uniformly distributed load and then we have concentrated action, which is 1.4 kilonewton. So this is what it means. So let me see. Okay, so once it says 1.4, this is point load 1.4 kilonewton, live load, and then if I apply this 1.4 kilonewton, which is only 1 point, which is not very effective for the whole member, I need a load that will cover from here to here, then from here to here, which is the whole member, which is a series of line load, which is I'm going to convert my area load into a linear live load, which is that is very effective to get a bending moment. And finally we're going to get a member size. So for now I'm going to ignore this concentrated action. So I'm going for this area load. So area load is at 1.8 over A plus 0.12, but not less than 0.25. What it means is you're going to get 1.8 divided by the area, which is the triplet area for that is considered for a structural member. So the distance from here to here, which is 10, which means we're going to take half distance from here to here and then from here to here, and then that distance from from here to here, which is 15. So going back to Excel, 1.8. Okay, so 1.8 divided by, which is my area, 15 multiplied by 5 this is the triplet area, then plus, remember the formula, plus 0.12, which is way beyond 0.25. So the code says that when the value is less than 0.25, you have to get the value of 0.25 kN per meter square. So this is the value of my live load. Right. So now that we've finished with our live load, next thing that we need to do is we're gonna start defining our dead load. So in order for you to get the value of the dead load, go to the table and go to table A2. Go to the table that says value for roof and scroll down until you find steel galvanized standard corrugated sheetings. So I'm going to get this value 0.12 kN per meter square. Okay, 0.12 kN per meter square. Okay, seating load. I've seen it somewhere. This is my ceiling, yeah. So ceiling load, I'm going to go for suspended metal ceiling with a fire rating of 1 hour. This is the actual standard that we normally use for office building. 1 hour rating. So this is 1 hour. 1 hour rating, yeah. Fire rating. And finally, we're going to get the value for our balance. So in order for us to get the value dead load for balance, we have to assume some initial section sizes. So as you can see, this manual. So we can choose any value from here. I think based on my opinion, I can choose, let's say, this Z15024. So this is the mass 5.7 kilogram per meter. So Z15024, which is 0.050 kilonewton meter per meter. It's not per meter square, it's per meter. So the next thing I need to do is I'm going to convert this load into a point load. So let's assume that this balance are closely spaced at a distance of 900 millimeter center to center along the rafter, which is along the rafter here, 900 millimeter center to center. So what I need to do is I'm going to convert this line load into a point load. So for that, you see the distance from let's say if I want to consider this rafter, the distance from here to here is 5, and then the distance from here to here is 5. So total is 10. So half weight of the purlin is taken by this rafter, then half weight of this purlin is taken by this rafter. So to get the value for the point loads, I'm going to take half distance of this one, then half distance of this distance that is below this. So I'm going to my Excel, I'm going to take the value of this one and then multiply by 5, which is 2.5 plus 2.5, which is equivalent of 5 kilonewton kilonewton. That's a point load. So since these pylons are closely spaced at the distance of 900 mm center to center, which form a series of line load along this rafter. So because like what I said, the pylons are closely spaced, we can say that at every point load form a series of line load which is on the rafter. So therefore the line load as the load of pylons on rafter is equivalent to this value here, which is equivalent to here, but now it's not kilonewton but it's kilonewton per meter, because they are centrally closed at a distance of 900 mm. So the form is another series of line which is along the rafter now, because usually when we say that kilonewton per meter, it is a series of load along a member which is a distance is considered by 1 meter length. So same scenario with this case, 0.285 kilonewton, which form a series of line load because the pylons are closely spaced at 900 mm center along the rafter. So that's how we define our dead load on the rafter. So what I need to do is total dead load. Sorry. Here, then this is my total live load. So this is the values you are going to use when you assign our load on the rafter. So in the next tutorial we are going to assign and define our wind load, wind wall, leeward, side wall on the wall as well as on the rafter. So thanks for watching. I'll see you again in the next video.